the Unit 3E, which is How Numbers Can Deceive. This is the first lesson after the MyLabs orientation that you will do in MyLabs. The learning objectives are: understand the concept of false positives and false negatives, and determine claims about the same data set. Numbers in the real world. Comparisons. Kevin had a higher shooting percentage in both first half, 40% to 25%, and in the second half, 75% to 70%. Does this mean that Kevin had a higher or better shooting percentage for the game? Let's look at the table. We have 3 rows and 7 columns. The first column labels. So the first column states the player, and it has Kevin below that and Kobe. The next column is baskets, attempts, and percent for the first half. Kevin had 4 baskets, 10 attempts, 40% success. And in the first half, Kobe had 1 basket, 4 attempts, and 25% success. On the second half, Kevin had 3 baskets, 4 attempts, 75% success, and Kobe had 7 baskets, 10 attempts, and 70% success. Let's look at the solution. Actually, no. Kevin made a total of 7 baskets, 4 in the first half and 3 in the second half on 14 shots. 10 in the first half and 4 in the second half, for an overall shooting percentage of 7 divided by 14, or 50%. Kobe made a total of 8 baskets on 14 shots, for an overall shooting percentage of 8 divided by 14, which computes to 57.1%. Even though Kevin had a higher shooting percentage in both halves, Kobe had a better overall shooting percentage for the entire game. Test results. How accurate is your test? To receive the antiviral for flu, you must have a positive test for flu. Consider the following scenarios for a medical test for the flu. The lab can analyze your sample, and there are more than one possible outcome. True positive. A test correctly reports a positive result. If this were pregnancy, then you are pregnant and the test says you're pregnant. False positive. A test incorrectly reports a positive result. So you are not pregnant, but the test says you are. A true negative. A test correctly reports a negative result. So you are not pregnant and the test accurately says you are not pregnant. And false negative. A test incorrectly reports a negative result. So you're pregnant, but the test says you are not. Example, false negative. Based on the numbers in Table 3.7, what is the percentage of women with negative test results who actually have cancer? That is false negatives. Table 3.4, title is Summary of Results for 10,000 mammograms, in which 100 of the women have malignant tumors and 9,900 have benign tumors. The table has 4 rows and 4 columns. The first row has the title of Tumor is Malignant, followed by Tumor is Benign, and then finally Total. The first column begins at the second row, and it is titled Positive Mammogram. The third row is titled Negative Mammogram, and the fourth is titled Total. Reading horizontally across, starting with Positive Mammogram, and coincidental with Tumor is Malignant, the number is 85. Moving to the right, the Tumor is Denied, false positives, the number is 1485, so the total number of positive, whether true or false, is 1570. Third row says negative mammogram. Under the tumor is malignant, we have 15, so false negatives, 15. Tumor is benign, true negatives, 8,415 for a total of 8,430. In the total row, we read across and find out that we have 100, whether positive or negative test, tumor is malignant, and we also find out that we have 9,900 tumor is benign, whether it is false positive or a true negative test results. The third column is tumor is benign, and the sum of the numbers in the next two rows, that's 1485 and 8415, is 9,900, and it totals in the very bottom right corner to 10,000. Now that we've looked at the table, let's analyze the results. Solution. For 10,000 cases summarized in Table 3.7, the mammograms are negative for 15 women with cancer and for 8,415 women with benign tumors. The total number of negatives is 15 plus 8,415, or 8,430. The percentage of women with false negatives is 15 divided by 8,430, or computed in your calculator 0.0018. Converting that decimal expression to percentage will be 0.18%, or slightly less than 2 in 1,000. In other words, the chance that a woman with a negative mammogram has cancer is very small. Let's go to polygraphs. Suppose that 1,000 people take the polygraph test, 10 of whom lie, and the polygraph is 90% accurate. How many of those applicants who were accused of lying were actually telling the truth? Let's look at the solution. We will make a flow chart starting with 1,000 applicants and having a line connecting to the left with a box that has 10 lie, and a line connecting to the right to a box that has 990 tell the truth. From the 10 lie box, we have two arrows coming. To the left, polygraph does not catch, and so that's 10% of 10, or one liar. To the right, we have polygraph catches, so 90% times the 10 who lie, or 9 liars. And then let's go to horizontally across to the 990 tell the truth box. There are two arrows coming out of it. To the left states polygraph falsely accuses. So 10% of 990 is 99, and polygraph finds 90% of 990, or 891 people truthful. Let's note that 9 plus 99 equals 108 accused of lying, but 99 of these are falsely accused. Example, high school drug testing. All athletes participating in a regional high school track and field championship must provide a urine sample for a drug test. Those who test positive for drugs are eliminated from the meet and suspended from competition for the following year. Studies show that at the laboratory selected, the drug tests are 95% accurate. Assume that 4% of the athletes actually use drugs. What fraction of the athletes who fail the test are falsely accused and therefore suspended without cause? Let's look at the solution. Okay. Notice we weren't given the number of athletes participating, but it's all in terms of percentages, so let's pick a nice power of 10 for the number of athletes. We'll assume there are 1,000 athletes at this meet. By the way, if you choose 50 athletes, 10,000 athletes, 100 athletes, the results will be exactly the same. We are told to assume that 4%, or 40 athletes, actually use the drugs. The remaining 960 athletes do not use drugs. In that case, the 95% accurate drug test should return the following results. 95% of the 40 athletes who use drugs, which would be computed as 0.95 times 40 equals 38 athletes. test positive. The other two athletes who use drugs test negative, so they kind of get away. Now, 95% of the 960 athletes who do not use drugs test negative, but 5% of these 960 athletes test positive. The number of athletes who fail despite not using drugs is 0.05, which is 5%, times 960, or 48 students. The total number of athletes who test positive is 38 plus 48, which equals 86. But 48% of these athletes, or 48 divided by 86, which computes to 56%, are actually non-users. Despite the 95% accuracy of the drug test, more than half of the suspended students are innocent of drug use. Example, political math. Consider the two charts shown. Both purport to show effects of the tax cuts enacted under President Bush in 2001. The chart on the left-hand side, A, created by supporters of the tax cuts, indicates that the rich ended up paying more under the tax cuts than they would have otherwise. The chart on the right-hand side, B, created by opponents of the tax cuts, shows that the rich received far more benefit from the tax cuts than lower-income taxpayers. The two charts therefore seem contradictory because the first seems to indicate that the rich paid more, while the second seems to indicate that they paid less. Let's analyze. Both of the graphs are accurate and show data from reputable sources. The tax cut supporters show the percentage of total taxes that the rich paid with the cuts and what they would have paid without them. The opponents of the tax cut show the absolute dollar savings, which show that the largest benefits went to the rich. Let's look at the graphs. Rich pay more under tax cuts. Note that the pink bar is the Treasury estimate for share if tax cuts had not been enacted. Notice that the percentage is lower, an actual share with the tax cuts in place. So the tax cuts did end up making the rich pay a higher percentage of their earned income. Now, high-income households receive higher dollar benefit from tax cuts. On this chart, let's note that as the annual income increases, it appears to indicate a larger amount of tax cut for more money that you earn. So, how do we conclude this? Both of the graphs are accurate. Let me repeat that again. Both of the graphs are accurate and show data from reputable sources. There is no bias or agendas with the graphs. So the analysis is neither a better or a more honest representation of the data. The supporters focused on relative change or percentage in order to mask the absolute change. The opponents focused on the absolute change and neglected to mention the fact that wealthy pay most of the taxes.